What we're going to do in this video is talk about percent composition and teach you how to do percent composition problems in chemistry. We'll start with a little bit of a discussion and then we'll do 3 practice problems together. So you want to make sure that you have this packet, your periodic table, and a calculator with you so you're ready to go. Percent in chemistry means percent just like it does in math class. So when we talk about percent in chemistry, we're talking about part over whole times 100. So part over whole times 100 is what we mean when we're talking about percent in chemistry. In chemistry, the part is going to be the mass of an element, and the whole is going to be the mass of a compound. Those two numbers can come from the periodic table. So if we look up here at this definition of percent composition, it says it's the percent by mass of each element in a compound. It can be determined experimentally or by doing the math if the formula is known. And we'll show you both ways during this video. Here's your formula that you're going to refer back to. Percent composition, again, equals mass of element over the mass of the compound times 100. Let's move on to the first practice problem and I'll show you an example. The first question says find the percent composition of copper 1 sulfide. In order to do this, you need the formula of copper 1 sulfide. So we have to figure that out first. We are going to look at the copper, and the formula for copper is Cu, and this one tells me that it has a 1 plus charge. And if you look up sulfur on your periodic table, you'll see that sulfur is a 2 minus charge. So the formula for copper 1 sulfide, if you crisscross, would be Cu2S. So I'm going to do 2 problems here. I'm going to find the percent copper, and I'm going to find the percent sulfur. So I'm going to set up my equations here. We're going to do part over whole of each times 100. So for the percent copper, I can see that I have 2 copper atoms in this molecule. So I'm going to look on my periodic table, and I see the molar mass of copper is 63.546. So I'm going to take 63.546 and I'm going to multiply it by 2 because again we have 2 copper atoms in this molecule and the mass is 127.092. So again that's the mass of 2 coppers from the periodic table. Then I'm going to look up sulfur on the periodic table, and with sulfur I'm only going to include 1 because there's no subscript here. And I can see on the periodic table that the mass of sulfur is 32.066, and the unit on these would be grams per mole. Now that's the part of each, so now I need the whole on the compound. And the whole that we're going to use is the mass of the whole compound, 2 coppers and 1 sulfur added together. Well, if I take this number, this is 2 coppers, and add it to this number, 2 sulfurs, I can get the number that belongs on the bottom. So 127.092 plus 32.066, and I get 159.158. Now, of course, you don't have to use this many decimal places. You can feel free to round. Okay, and that would be grams per mole. So now I have part of copper over the mass of the whole compound, part of sulfur over the mass of the whole compound. So I'm going to do the math. These we typically round to 1 decimal place. So 79.9% copper. And this one would be 20.1% sulfur. Now at this point, students typically ask me, well, if I've calculated one, do I really have to calculate the second one? Because I can just subtract 79.9 from 100 and get the second one. And that's true. You can do it like that as long as you show your work. But I think the advantage to doing both the calculations, if you look at these 2 numbers and you add them up, they should come out pretty close to 100, and then that's a way that you can tell that you've done the problem correctly. So that would be our first example of a percent error problem. It said percent composition. When it says percent composition, that's just kind of a blanket statement that says you have to do each element in the compound individually. So if we had the compound Na2SO4, we would do the percent sodium, the percent sulfur, the percent oxygen. So again, you're just doing the percent for each element that's in the compound individually. Let's move on to another practice problem. So the second question says, what is the percent carbon in carbon dioxide? So this question's a little bit different because it doesn't say percent composition. This time it just asks you for the percent carbon. And we know the formula for carbon dioxide is CO2. Since it asks for just the percent carbon, I only have to do one calculation this time. I'm going to do the percent carbon. Normally, if it said percent composition, I would also find the oxygen too, but in this case, that's not necessary. So I'm going to do the percent carbon. It's going to be part over whole times 100. So I've got one atom of carbon in this molecule. And if you look on the periodic table, the molar mass of carbon is 12.011 grams per mole. And then for the bottom, I've got to find the mass of the whole compound. So you would take that 12.011 for carbon plus 15.999 times 2 for oxygen. And the mass of the whole compound comes out to be 44.009 grams per mole. If I do my math, 12.011 divided by 44.009 times 100, you get 27.3% carbon in carbon dioxide. Again, this is percent by mass, so we're using the molar masses from the periodic table. The third type of problem I can give you is when instead of giving you the percent, I give you the mass. So this would be kind of like if you did an experiment and you had some experimental data that you were going to find the percent composition using that data. So this question says a sample of a compound contains 53 grams of sodium and 37 grams of oxygen. Calculate the percent composition. Well, in this problem, it says that we have sodium, so we'll do percent sodium, and then it says we also have oxygen, so we'll do the percent oxygen, and again it's going to be part over whole times 100. So let's see, I have 53 grams of sodium and 37 grams of oxygen, and if I add those two up, we get 90 grams, which would be the mass of the whole compound. So if you notice, this time we didn't have to use the molar mass from the periodic table because the masses were given in the problem, 53 grams of sodium and 37 grams of oxygen, and we could just use those. So if I do the first calculation, this time I'm just going to keep whole numbers because there's whole numbers in the masses. So it'd be 59% sodium and 41% oxygen. And if you take a look at those two numbers, 59 plus 41 does come out to 100%. So we can tell that we've probably done something right in this problem. So there you've had 3 example problems of percent composition. Remember, you're just taking part over whole for each one. Typically we're going to use the molar masses when they give us the formula. Unless they give you the grams, then you can just use those masses directly. Good luck on your practice.